All right, welcome back to Lag Demon Programming. In our last video, we got our system set up with a little bit better expression processing and stuff, and fix some things up. In this video, we're going to take a look at making a command line parser, and so let's get to it. Next, what I want to think in terms of is the idea of having a command line parser. So what I think I want to do, and I'm probably going to sunset my introduction to C++ series, where we're building the dungeon crawl, and move the dungeon crawl game over to here, because what we want to be able to do is do a lot of parsing, and it's very cumbersome to do it without using some sort of parsing tools. And there's a variety of them. There's different directions you can go with this kind of parsing. But I happen to like these tools, and I think they're very fundamental and something we should use. There is a way to make this more like a command line parser. It's sort of okay right now. We can type in stuff, but the thing is the parser's continuously running while we're doing this. And what we want to do is parse a single command line and return some kind of result that we can use to decide what to do. That way we can create commands to control a game like a dungeon crawl. So to do that, what we're going to do is over here in the parser is we're going to modify this main function. And we're going to bring in some additional functions that are supplied by our parsing system that we're building. So understand that what these tools do, what Flex and Bison do, is Flex parses the lexer.l file, and it generates a C++ file. And Bison parses a parser.y file and generates a C++ file. So those two then work together with this YY parse function, which calls internally the lexer function that's going to do the lexical analysis to run through this. So really these tools, Flex and Bison, are compilers. But they're compiling this weird code that we write. Doesn't look much like a program. It's more of a description file, and that's exactly really what it is. It's a description file with some code in it. It actually expands when it parses this. It expands these out to actual variables, and we can look at that. And down the road, I'll show that to you. It's the C++ code is a bit complex and uses a lot of very strange techniques, but we can certainly look at it. That actually expands these into real C++ code, where these are actual variables within the system, and this math and other stuff gets done correctly according to that. So what we want to do is be able to have this main function actually be in our main function here. So we're going to change that right now. And this basically does the same thing. So we're going to prove it out and make sure it works by renaming this. And I'm going to call this eval. And instead of this, we're going to pass in a standard string as a line. And we'll get back to that. Coming up here, I'm going to add include string so that that's in there, and this should still compile just to make sure. It doesn't like so. Oh, it doesn't have a start. It doesn't have a main function yet, so we need to go into cmakeLists.text, and we need to add main.c right here. So now, or excuse me, cpp right here, so that it's got that main function, and now it can link. Okay, so it's working, and it actually should run exactly the same way it did before. We just run this, and we type in 2 plus 3, and we get 5. So it runs exactly as it did before. What's happening now is that this main function is being called, and look at that, it does the same thing. It prints out this YY parse and returns 0 just for testing. Okay. So to process a string over here in this main function, we need to bring in some. Some stuff in first. We need to do some. What I'm going to do is I'm going to copy paste this in, and then I'll explain it, what it is and what it's about. So We can put this up here right above YY error. We'll paste this in. So this first line is what's called a type def. Hopefully you're familiar with C++ enough to know what a type def is. It's defining this YY buffer state as this YY buffer state pointer. That's all. It's this struct YY buffer state pointer is what YY buffer state is. And then we've got some external functions that are supplied by the scanner, and they are scan string, scan buffer, delete buffer, and switch to buffer. And we're going to use those down here in the main function. So what we will want to do, we're already bringing in our string line, is first of all, I'm going to get rid of all of this, all of it, because we're going to do this a little bit differently. So what we're going to do is use that YY buffer state, and we're going to create a buffer. And we're going to say that's equal to YY scan string, and we're going to pass in our line, and we need to have this be a CSTR function. That's a string object, and this takes in a character constant pointer. So hopefully you know about how const works, how constant works. A character constant pointer means that the pointer is constant and it can't be changed or modified. All right. The next thing that we need to do is switch to that buffer. So we're going to call YY switch to buffer, and we're just going to pass in this buffer. What that's going to do is tell YY Lex to use this buffer we just created that's got our string in it. So we're going to pass it a string, and it's going to YY Lex is going to read from that buffer instead of reading from standard in. And then we're going to create a return value here, which we'll just call RV, and that's going to equal YY parse. Very simple. But now, because we supplied the buffer, we need to clean up the buffer. So we need to go YY delete buffer and pass in that buffer, because we created a, by calling this, we kind of newed up a buffer. We dynamically created it. This YY delete will delete the buffer, and YY delete handles any internal cleanup that needs to be done. Then all we have to do is return that RV. So now we have a little eval function that returns this. Now later, we're going to return something other than just int. We're going to return an object that will contain both this return value from the parsing and some data that's collected by this. But right now we're not collecting any data, so we're just going to return it. In fact, all we're doing is printing out the answers to the screen, and we're going to keep doing that until we get to that part. All right. So over here in main.cpp, well, we can do this a little bit differently now. All right. So let's go over to main CPP and let's get rid of this junk because we don't want to do that. All right. So I suppose the first thing that I can do, we want to include string because we're going to use it here. Pound include, or hashtag, whatever you want to call it. Hashtag pound. I'm very old. So this was a pound sign for a long time, and in the internet days it became a hashtag. I'm not sure where that came from, but it actually means pound. Okay, so sometimes I call it pound. So hashtag include string. So let's start by going standard cout. Oops. Welcome to dungeon crawl 2, we'll call it, since I'm doing that on the other one. Standard endl. All right. Now what we're going to want is what's called a read eval print loop. So if you went through the intermediate, or you went through the introduction to C++, I created a read eval print loop in that. We're not going to do the print right now because our parser is printing out. All we're going to do is do the read eval part. So it's pretty simple. The first thing that I want is a function called, we'll call it print prompt, and it will take a standard string prompt. This will allow us to change the prompt that gets displayed depending on what mode the thing's in later on, so I want to have it there now. And so all we're going to do is very simple. We're going to go standard cout from prompt, and that's all. We're not going to do an endl. Oh, yeah, prompt. Yep. And then we're going to go standard cout dot flush. And the reason for that is we're not doing an endl. If you do the endl, it'll automatically flush the buffer to the screen. If you don't do an endl, it won't. So this way our prompt will go and our cursor will be right at the end of the prompt, no end of line, unless we were to put it in. Now we need an eval function here, and we're going to call it differently because we've got an eval function over there. So we're going to call this eval command standard. Oh no, before we do the eval command, we need to read a line. So it only takes, it's very simple to read a line, but we'll make a function that does it. We'll go standard string read line, and that's just going to return that string. So what we'll do is we'll go we want to go standard string, we'll call it line. We want to do standard get line, and it's going to be standard. We want to get it from cin, which is the input stream, and we want to send it into, put it into our line string. So it's going to write it into this string that is our return result, and then we're just going to return line. So that makes it very easy to read the next line. All right, now we're going to have an eval function. So for now, we'll just make it void. We'll call it eval command because it's going to call that other one. Now there's something we do need to do here. Over in parse y, this int eval standard string line, we need to have a prototype of that over here so that we can access it, and it's going to be extern. We need to tell it that it's external from this module, and that it'll show up during linking is what will happen. And that tells the compiler how to call it here. So eval command is we're going to get a standard string line in here, and what are we going to do? Well, we're going to call we're going to say int result equals eval line, and then we're going to say if, and I'm going to show you why, equals 1. What we're going to do is actually, you know what, I'm going to make this bool, and I'm going to say return false, and down here we're just going to say return true. And the reason for that is we're going to do this. We're going to make our read eval print loop now. So first thing that we want to do is go, we'll do a do loop while, and we'll say bool running equals true while running, and then ing. There we go, while running. And so what do we want to do? Well, we want to print the prompt, and I'm just going to call it, we'll say dungeon, and we'll do this with a space. So we're going to print the prompt. We're going to go, and we can combine these. We can say running equals eval read line. And that's it. That's our print eval print read. That's our REPL read eval print loop. So what's it doing? It's going to put up a prompt. It's going to call this read line, pass the result into eval, and that's going to be running. What are these going to do? Well, read line gets us our line. That gets passed into eval. If the result is equal to 1, we're going to return a false. That means we got some sort of an error condition out of our thing over there, out of our parser, and so we're going to quit the loop. We're going to use that for our quit command as well, which we're going to do in just a second. So let's make sure that this does some basic work here. Let's do a make. I guess I'll go over to here to run it so it's a little bit bigger. We'll make this a little bit bigger. How's that? We'll make it a lot bigger. And so we'll run it, and there, it came up with dungeon, and now we can type 3 plus 2. Now our commands aren't all that great, but we get a parse error. 3 plus 2. Why are we getting a parse error? Interesting. What did I do wrong? So yeah, I seem to have this habit of doing weird things here, even though I have notes and everything. Why doesn't it like it? Oh, I know why. There's one other thing we need to eliminate, and that's these new lines, because we're not sending new lines anymore. We're sending a string, and there's no new line in that string. It is a single line, so when the string ends, it ends. So each string is a line, and what we can do is go over here to our lecture.l, and we can move this slant end back up to white space in case there is any there, though there shouldn't be. And we don't want to return new line anymore, and this needs to be a lowercase n. And then we can do a make. Okay, and we can go back to here, and things should run a little bit better now. 3 plus 2. The answer is 5, and we quit. Why did we quit? Probably because I did something wrong. So result equals 1. We'll return false otherwise. So result must be coming back 1 for some reason. Parse.y. Return IV. Well, one thing we need to do here is have a possible error condition, in which case we will abort, I believe is what it is. Let's do a make. Excuse me, let's do a make and make sure that works there. And let's try it again. Three plus 2. And it just quit. Interesting. Main. Do while running. Running equals true. Running equals eval. Let's comment that out temporarily. And see. I might not have set everything up right to do that. Let's see if we can get it repling now. 3 plus 2. And it still quit. So it's not running equals true. This should keep running. Eval is just returning true. Very well. This is very strange. Why is that dying? Is it crashing? Let's change this to while running. back to the bigger one so you can see it. Let's see here. 3 plus 2. And we still died. Okay, this is very strange. It's calling eval. Let's try a debug statement. Let's go cout from running eval from endl. One, two, three, 4, and I'll just number these so we can see where they come out. This will be, oh, come on, what's wrong with this now? Space. What? What's wrong? Oh, I guess my, what? I'm running it a virtual machine, and it might be running a little low on memory or something. Limit this 1, 2, 3, 4, 5. So this is kind of like trace statements to see if it's crashing somewhere. So let's do a make. Come back here. Run it. 3 plus 2. Eval 1, 2, 3. The end answer is 5. Running for 5, and then it exits. Okay, have I done something silly here? So it's not crashing in here. This is all running perfectly. Main.c. Running equals true. Return true. Running equals eval read line. Why would... I'm going to pause the video for a few minutes and see if I can run this down. Okay, this was a bit of a brain fart. Wait a minute. Prompt dungeon. Let's get rid of this. Get rid of this. Running equals eval command. We can get rid of this. I put a whole bunch of, yeah, more. I put other, so we can get rid of all of these printouts. They're not very nice on the screen. All right, I'll explain what I did. So I called eval. Yeah, eval is this one over here, and it returns an int, and it returns 0, and that's why it wasn't eval command. You probably saw that. You're probably sitting there yelling at the screen going, eval command dummy, running equals eval command read line, not eval. So, yeah. So we can do a make, and we'll go over to here, and it looks like we can do this, and we can go 3 plus 2, and we can go 4 plus 5, and it's just REPLing now. And if we hit enter, well, we get a parse error. We want to fix that right now real quick before we go, and I think we're going to end the video here, and we'll pick up the rest of this in the next one. What we want to do here, eval command read line, we really don't want to do that. We want to go standard string line equals read line, and if line dot length is greater than 0, then we want to do the running equals eval, and not read line but rather line. Okay, and this will allow us, we'll build it real quick, okay, we'll pop over here real quick, we'll run it, and this allows us to hit enter and just get a prompt. But if we type something that it doesn't understand, we'll get a parse error, and we will in the next video start creating commands like quit, and we'll start maybe creating some other commands to do different things and evaluate things in different ways and make variables and all kinds of stuff in another video. So this video went really long. It's like 52 minutes. I might trim that down a little bit. We'll see if I can. I packed a lot of stuff in here though, and I don't want you to miss anything, so maybe I'll have to split it in two and put a little break in there and have it in a second video. We'll see. So anyway, thanks for watching. I hope you enjoyed it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video.